The creation of the Suez Canal, navigating engineering marvels. Introduction. The geographical challenge * geographic barriers often shape trade routes and cultural exchange. The Suez Canal, opened in 1869, serves as a transformative solution to connecting the Mediterranean Sea with the Red Sea, facilitating seamless navigation between Europe and Asia. More than just a waterway, it symbolizes the ingenuity of engineers and the boldness of visionaries who tackled monumental technical and environmental challenges. Context. The historical landscape * as the 19th century began, global trade expanded, particularly thanks to industrialization in Europe. The British Empire sought faster routes to its colonies, avoiding the lengthy journey around Africa's Cape of Good Hope, a detour adding thousands of miles and weeks to voyages. This dire need for direct trade routes spurred the idea of the Suez Canal, a concept that dated back to ancient Egyptian and Greek civilizations, with Ferdinand de Lesseps, a French diplomat and engineering enthusiast, announcing the canal's construction. A wave of hope mingled with skepticism. Engineers faced daunting terrain with its deserts, diverse soils, and fluctuating water levels, yet they were motivated by the potential to revolutionize international trade. The mission was clear: create a navigable waterway accommodating contemporary ships while resisting local environmental challenges. The engineering challenge, designing the canal. Creating the Suez Canal involved crucial components. First, mapping the land accurately dictated its path, over 100 miles long, traversing sandy terrain and marshes. Engineers needed precise calculations for water levels and dredging to ensure adequate depth for ships. Secondly, the elevation difference between the Mediterranean and Red Seas posed a challenge, with the former being about 3.7 feet higher at low tide. Engineers designed water control structures to maintain consistent canal water levels, preventing sand collapse into the waterway while mitigating flood risks. Developing the solution. Steps toward realization. Extensive surveys marked the first step towards realizing the canal. Engineers and laborers mapped Egypt's geography, employing advanced surveying techniques to finalize the canal's trajectory. The proposed route featured numerous curves and required lakes to control water flow and accommodate vessels. Bitter lakes were pivotal as reservoirs. Construction was segmented into the western approach, central section, and eastern approach, each unique in challenges, necessitating careful planning regarding soil stability and resource transport. Key systems and mechanisms. Engineering the canal. The Suez Canal's construction hinged on effective dredging techniques, notably the cutting and filling method, excavating earth to elevate canal banks. Steam-powered dredgers revolutionized excavation speed and depth. Temporary wooden bridges facilitated worker movement. Many local Egyptians collaborated to maintain a steady workforce, aware that the canal's successful completion held economic promise for French interests, imposing a strict timeline. Difficulties and breakthroughs. Overcoming adversity despite meticulous planning, challenges persisted, including extreme heat and health issues among workers, compounded by labor disputes and high disease-related mortality rates. Testing new materials emerged as a key breakthrough after dam breaches threatened canal integrity. Engineers used impermeable surfaces of lime and compacted earth to stabilize banks and enhance water retention against sand infiltration. Hydraulic management posed another challenge. Engineers experimented with various lock designs, ultimately determining a system of lakes and canals to maintain water levels, ensuring smooth navigation despite drought or flooding. Impact and significance. The canal's legacy. Completed in 1869, the Suez Canal initiated a new maritime era. On its opening day, ships traversed its length, transforming travel and significantly reducing journey times between Europe and Asia, while energizing cities like Port Said and Suez. Economically, the canal catalyzed global trade, enhancing European, Middle Eastern, and Asian economies through swift goods exchange. It also stirred geopolitical ambition, intertwining control over the canal with national interests, prompting economic integration and diplomatic tensions. The canal's story continues with ongoing improvements and expansions, adapting to larger vessels and technological advancements. Its initial engineering principles paved the way for future monumental infrastructure projects. Reflective closing. The significance of engineering solutions. The Suez Canal transcends its role as a transport route. It represents engineering excellence amid adversity. The collaboration between engineers, laborers, and visionaries highlights the foundational effort in monumental projects. Challenges of material, geography, workforce health, and environmental factors were met with innovative solutions. In essence, the Suez Canal not only changed trade dynamics but exemplified engineering's role in bridging distances, shaping the global economy, and fostering international interdependence. As we navigate modern complexities, the lessons from its creation remain pertinent, demonstrating engineering's capacity to overcome challenges and generate transformative solutions.